All right, 3.3, dividing polynomials using synthetic division. So 3.3 and the next section, 3.4, actually go together, but this first part's going to kind of be more about learning how to do the synthetic division process. And so that's what I have right here. I have a very detailed example of this. And so I'm going to show y'all something real quick. Okay, so I created a little bit of space here because I do want to show you synthetic division it's kind of a trick. It makes life a little bit easier on this, but the original way that you may have been taught this before is long division, where you would take x plus 2 and divide it into this polynomial right here, 3x cubed plus 8x squared, and then plus 5x minus 7. And so a lot of times you'll learn this typically in like a high school algebra 1 or 2 course. And the way it works is it's pretty similar to where if you were to take, let's say, 4 and divide it into 800 and let's say 60 5, something like that. And so what you would do is you would try to figure out, okay, how many times does 4 go into 8? It goes into it 2 times, and then you do 2 times 4 is 8, and then what do? We would subtract it, right? And so that would knock that out, and then you'd bring what's left over, right? And you would continue the process. Well, it's going to kind of be the same idea here. So you could basically divide x into this, right? And that would give you 3x squared. So I'm going to line that up right here with my squares. So 3x squared. And then what you have to do is multiply it by the divisor. So 3x squared times x would be 3x cubed. And then 3x squared times 2 would be a plus 6x squared. And then just like I did over here, I would have to subtract this. So this would become a sign change. This would become a minus. This would become a minus right here. And what would happen is we would go ahead and knock that out. This right here would become 2x squared. And then we could go ahead and bring down what we have left from up above. And then we do the same thing again. So 4 goes into 6. In this particular example, it doesn't go evenly, so I'd have to put a 1 there. 1 times 4 is 4, subtract the 4, and then I'd be left with 25. And then I'll finish this off in a second. So I'm going to continue over here. So let's see, if I were to take 2x squared and divide it by x, that would become a 2x, so positive, right? So I'm going to put plus 2x here. And so then I go ahead and multiply it by my divisor again, just like I did on the first part. So 2x times x is 2x squared. Then 2x times 2 is plus 4x. Plus, there we go. And then once again, then we have to do the sign change because you're going to subtract it. So minus and minus. And so that will knock out that first one here. And then that'll leave me with an x minus 7. And then I would do the process all over again. So divide x into x. X divided by x is 1. So I'll put a plus 1 here. Then I have to multiply that by the divisor, which would give me x plus 2. And then once again, you have to change it to subtraction right there. And so that would cancel out the x's. And then I'd be left with the negative 9, which is actually would be my remainder, And so we'll talk about what to do with that in just a second. So now back to my other example right here. So then 4 goes into 25. It looks like 6 times. Okay. 6 times 4 is 24. And then what do? I subtract it. And so I'm going to have that remainder of 1 right here. Well, so I have a remainder of 1. You could write it like that. That's fine. But this would also be equivalent to 216 plus 1/4, right? Because I had a remainder of 1 over my original divisor right there, 4, which is basically, 216.25. And if you wanted to, if you were to put that into a calculator, 865 divided by 4, it would be 216.25, which is the same thing I have up above. But the way I wrote it here is the way we're going to write it. So what I would do here is I put plus and then put my remainder over my original divisor, which would be negative 9 over x plus 2. Okay, so like I said, hopefully you've done this before, but we're actually going to do a different way. We're going to use synthetic division, which is actually, it's a little bit easier. The first couple of examples you might kind of be like, this is kind of weird, which it is, but it's not difficult. It's actually a lot easier than what I just did right here. Okay, this can get pretty complicated and it can be easy to make a mistake. And so what synthetic division is going to do for us is, for a moment, it's going to remove the variables so that we can just kind of focus on the numbers, the multiplying, the adding, subtracting, all that kind of stuff. So you just kind of focus on the numbers for a minute, and then we'll put the letters back in place, the variables back in place when we're done. So let's go ahead and look at an example of this. And so I kind of wrote out a pretty detailed way that the process works, and they'll all pretty much work this way. So what you want to do is, step one, take the divisor, set it equal to 0, and solve for the variable. So here's our divisor, x plus 2, set it equal to 0, solve, so I would subtract by 2 on both sides, and so I get x equals -2. So that's step one. Step two is to list the coefficients of the polynomial that is being divided, and then draw half of a rectangle around those numbers and put the value from step one on the outer left side. So here, these are the coefficients: 3, 8, 5, and -7. So I write those numbers down, and then I kind of create this half of a rectangle, okay? And then I put that value from step one on the outer left side right here. And some people sometimes write this a little different, but it's essentially in this format right here. So you write the coefficients, you make this little half rectangle, put that value out to the left. This next part, what we're going to do is rewrite the first number inside the half rectangle below the horizontal line. So a lot of times we'll say drop it. So drop that first number right there, drop it. Okay. Then you're going to multiply that number by the value on the outer left side. So now you're going to take this number and multiply it by this number here, and then place that product below the second number in the half rectangle. So now 3 times -2 is -6, and I put it right there. Like I told you, this process is kind of weird, but it's not super difficult. So then what we're going to do now is add the two numbers in the second column of the half rectangle and put the sum below the line. So 8 plus a -6 is 2. Okay, then you're basically going to do the same thing you just did. You're going to multiply that value by the value on the outer left side and place the product below the third number inside the rectangle. So you're going to do the same thing again. 2 times -2 is -4, and you put it in the third column. And then we're just going to continue this pattern. So now let's see. We're going to have 5 plus -4, which would give us a 1. Then you're going to do 1 times -2, which is -2. So that's going to go right there into my last column, my fourth column. And then I add those numbers together, and that gives me a -9 right there. Okay, so what we did, let's kind of review. We basically removed the variables for a moment. Okay, so we have all those same numbers there. It's the same numbers I have up here, the 3, the 8, the 5, and then -7, right? So I just removed the x cubed, x squared, and x. And I follow this process. It's kind of a little weird, but like I said, it's not super difficult. And once you do this 2 or 3 times, you'll remember the pattern and you'll be fine. So the last part, though, very important, the number below the line represents the coefficients of the polynomial quotient resulting from the division. So these are going to be the coefficients for the resulting polynomial from the division. Okay, and if you go back up to my example up here with the long division, you can see right here 3x squared plus 2x plus 1, and then I have my remainder right there, right? So see, you're dividing the polynomial by x plus 2. Whenever you divide by an x, it's going to cause a reduction in the powers, right? So we know that whenever you divide, you subtract whatever the denominator power is off of the numerator power. And so that's basically what's going to happen here. So the numbers below the line represent the coefficients of the polynomial quotient resulting from the division. The degree, this is important, the degree of each term is reduced by a power of 1 from the original polynomial being divided. The last number is known as the remainder. If the remainder is something other than 0, okay, divide it by the original divisor and add it to the polynomial. So if you remember, the original polynomial was a degree of 3. We had 3x cubed plus 8x squared and so on. So we are going to drop it down by a power. So now it's 3x squared plus 2x plus 1, and then the last number is known as the remainder, and you can just tack it on, divided by the original divisor, which was x plus 2. Okay, so what we'll do here is we'll do a couple more examples. Like I said, this first section's kind of just about learning the process of synthetic division, and then the next section will be more of an application of it. And so let's go ahead and try these. Like I said, once you do a couple of these, the pattern, it's pretty simple. It's easier than doing long division. If you really, if you've been taught long division before and you prefer that, you're more than welcome to do that. But this is supposed to make our life a little bit easier. So step 1 is take the divisor and set it equal to 0 and solve. And so we get x equals -4. So that's going to be kind of like I like to call it my magic number, because that's the number that's going to help me throughout the process. Then what we're going to do next is we're going to list the coefficients of the polynomial being divided here. So it's going to be a 3, a -2, a -7, and a 5. And so go. And then what we're going to do here is we're going to put a half a rectangle around this, and then we're going to put that number on the outside, my magic number right there, which is -4. Give it a little bit more space here. All right, so then the next step is to go ahead and drop that first number right here. We're going to drop it down, and then now you multiply, put that result in the next column. 3 times -4 is -12. It's going to show up in my next column. Add those two numbers together, combine them, so that's -14. Then we're going to do -14 times -4, which should be +56. Okay. Then we add those numbers together, and let's see, we get a 49. Then 49 times -4, which is going to be -196. We add those numbers together, we're going to get -191. The numbers can get a little crazy on the homework, so that's why I kind of picked an example where the numbers might get a little large. Just use a calculator as needed. So now what we're going to do is we're going to put these back where they belong, right? We remove the variables for a moment. Now we're going to put the variables back, but we're going to reduce it by a power starting with this one and then just count down. So this will be 3x squared minus 14x, then plus 49, and then here I do have a remainder, so you just tack it on, so plus the remainder over the original divisor, which was x plus 4, right there. And here we go. And so right now, like I said, we're working on the process. You're not really seeing the benefit of this yet. You will get to see a little bit of that in the next part of this, though. But before we do that, let's go ahead and try example B. And looking at example B, do you notice anything a little different about the polynomial being divided as opposed to the first two that we did, example A and the one above? Is there something you notice that's a little different? Well, what I notice is I'm missing the x squared, and so that's actually very important. So if you're missing you start with the highest and you count down, and if you're missing anything, you actually need to go ahead and put a placeholder there. So I'm going to have to put a 0x squared there, then a plus 7x and a minus 5, and then we're going to divide that by the x minus 3 right there. So that's very important. If you don't put that there, it's going to cause you to get the answer incorrect. So if you're from your highest power counting down. If you're missing anything, you have to put a 0 in there. You got to put a 0 there. Okay, so our step 1 is to take the divisor and set that equal to 0 and solve. And so this time it looks like my magic number is going to be a 3. My magic number is a 3 that I'm going to be working with. Then what we're going to do is take the coefficients of all these right here. So 2, 0, 7, and -5. So 2, 0, 7, and -5. And we're going to make that little half rectangle around it. And then I'm going to put that little special number over here, 3. And so we'll go ahead and drop the first number. And then you do your process. 2 times 3 is 6, and then we're going to put it in the next column. And then combine those. So 0 plus 6 is 6. 6 times 3 is 18. Once again, we'll combine those. We'll add those together. That's 25. 25 times 3 is 75. Then we add those together. That gives me a 70 as my remainder. So now it's time to put the variables back. So we had x cubed as my leading power here, and we're going to drop it by 1 power. So that's going to become 2x squared plus 6x, then plus 25, and then plus my remainder over the divisor. The original divisor was x minus 3. Okay, so that's kind of a little introduction to synthetic division, and so I'm going to go ahead and stop here and start another video, but we'll just kind of continue to really kind of practice the process of doing this. Like I said, students don't typically have problems with this. They just need to do it a couple times, and they get the pattern down, and it's not really a big issue. And so that's really what this section's about, because the next section that we will cover will be the application of using this.